What, Brett? And what happened? Do this as painlessly as possible and as quickly as possible. Exponential function can be written in the form. Are you going to cause a scene sitting up here, Adam? Do you?
Yeah.
So last year, you're right. You're right. We did. We did the little real life project. Didn't y'all do that one?
Yeah, I did too. Actually, I did. I did too. Miss Vicky, I was a chemist like your husband. I sold crap.
Okay. This is, I do remember, actually. Y'all's posters are probably up there on top of the... Yes. I remember. Okay. Were you really? This is different. We've done something very similar. We did monomial functions. And remember, monomial functions, the variable is not up here. With exponential functions, my variable is the exponent. Okay. My b is my base, and that determines what is growth and decay. Do you remember how it determines that?
Over 1 growth and less than 1.
See, I told y'all you would remember this. If b is bigger than 1, it is growth. If b is less than 1, oh, it's not supposed to be. Thank you, Khalil. It's
nothing.
Well, 1 to the x would just be 1, so it's not an exponential anymore. Remember, b cannot be negative. Why can b not be negative? What happens if it is negative? What does that really mean? If I had y equals negative 2 to the x, the a is negative. That's exactly right. That means a is negative 1. And if a is negative 1 in front, that means I'm really dealing with a what? What happens with the negative in front? What does the negative in front? It flips it. It flips it. So here, b can never be negative. Do y'all remember this? Because I'm kind of doing a general... A is the only thing there that can be negative. So let me give you some examples. Let's see if you do remember. Is that an exponential? Growth or decay? Why? That's exactly right. How about... exponential or nah? No, this is not exponential. To be exponential, that exponent has to be the variable. The variable has to be the exponent. How about... Yes, it is exponential. Growth or decay? It's a growth. Even though it's negative in front, that negative simply flips it upside down. It doesn't have anything to do with it being growth or decay. What if I asked you to find h of 2? What does that mean? If I plug in 2 for the exponent, and a lot of you missed this when we were doing some evaluation. Do I multiply first and then raise to the exponent, or do I exponent and then multiply? Always exponent first. So I need to do 1.5 to the second power first. Somebody with a calculator tell me what that is. 22.5, is that 2.25, I mean? Is that it? Okay. And then times negative 2, 4.5. Everybody okay there? What if I asked you to find h of negative 2? Yeah. That's a good question. So if it was negative 2 to the x like that, this is the same thing as negative 1 times 2 to the x. So you do 2 to the exponent and then multiply by negative 1. Right. This and this are different. This says to raise negative 2 to that exponent. This says raise 2 to the exponent and then do the negative. How about h of negative 2? Okay. You what? Go ahead, Khalil. And what does that do?
Flip it.
It flips what?
One, under 1.5.
Let's make 1.5 a fraction so you can really see what's happening. What 1.5 is a fraction is what? 3 over 2. What's it flipping? It's going to both of these, but it really makes this 2 to the positive 2 over 3 to the positive. Because that negative exponent is what flips it. Calculus has been getting really hung up on these type of rules, so make sure you understand them. Negative exponents flip. If it's a negative outside of a fraction, you can make a positive and flip the whole thing and take it to both, and that's okay. So this would be negative 2 times 4 over 9. Should, of course, be 8. Does that make sense to everybody? Yes, no, makes sense. What? Of course it's. Can everybody do that? Well, so I kind of skipped a step there. Let me show you. This is 3 to the negative 2 over 2 to the negative 2. So then this one moved down and became positive, and that one moved up and became positive. Oh, I don't know. It dropped. I don't know. It shouldn't have. Sorry. Other questions? Everybody okay? Before we talk about the graphs. Yes, I'm so glad. Remember what a growth versus a decay looks like? I have a horizontal asymptote, right? This is growth. For the parent, yes. So, yes. So, if I'm in this situation, this one's decay, which is the parent graph. Now, it could vary for us, and actually, I shouldn't say A, I should just say B to the X is the parent graph. This one, of course, B is greater than 1, and this one, B is between 0 and 1. My asymptote, my horizontal asymptote is always at y equals 0. And so that doesn't change until I start shifting it. And we talked about shifts last year, but we didn't focus as strongly on shifts as what we will or what we have been this year. And so that's what causes remember I'd always told you just take that little number on the end and that's your horizontal asymptote. Y'all remember that? So in this case, the reason though, there's no number on the end, there's no shift, it starts at 0, and as you shift up and down, that's what shifts your asymptote, your horizontal asymptote. Let's write equations of the graphs.
Show one if it's negative, like the high.
So if I had something like negative b to the x, it just falls below the asymptote that way or that way. Feel okay? I don't want to do anything that I don't really have to do. Right? I'm going to give you a table of values. And we're going to write the exponential equation based on those values. I'm going to pull this straight from the book. Let's see. Let's say I had x. You have a couple homework problems that are formatted exactly like this. So I'm going to do the same. You understand I'm talking about two different graphs here if I write it this way. I'm going to give you a second to copy all this down before I start talking about it. Ready? I'll take that as a yes. Well, that's the first thing I want to ask you. So I'm going to start by telling you that these are exponential. How can you tell? You're thinking, so at -2, so let's think about what this looks like. At -2, -2, I'm at 4/9. At -1, I'm at 4/3. At 0, I'm at 4. At 1, I'm at 12. At 2, I'm at 36. You're getting confused with the x versus the y. No, these. That's when we're modeling real life stuff. When we're talking about years versus something, we'll stay in the first quadrant. Yeah. Okay. Well, my graph just gave away the answer to the next thing that I was going to ask you, but you can tell that it is exponential because it is being multiplied by something each time, as opposed to just a constant adding of a value, which would indicate that it was linear to me. All right, so let's think about it for just a second. If I know that they're exponential, this one is obviously going to be what? growth. How about the h of x? Decay, right? At -2, I'm all the way up at like 128, and then I come down to 32, and then I come down to 8, and then I keep inching down this way, so it's going to look kind of like this. How could I write an equation for g of x and h of x? Any ideas? How do you know? A is 4? You think so? How did you get that? What'd you do? That's exactly right. Try to use your point for x equals 0 to find your A. There she is. 0, so 0, 4. And if I think, remember, I've got A times B to the x. That's my general form for my exponential for right now. So if I use 0, and Alex was exactly right, because anything to the 0 power is 1. So if 4 equals A times B to 0, well, then I know that 4 must equal A, right? So once I've used that, if I have that point, it makes writing the equation a lot easier. I don't have to set up a system or anything like that. So the next thing I'm going to do is I'm going to use my A and another point to find what? What am I looking for now? B. I still need B to write my equation. It doesn't matter what other point you use. I would use something that was probably the easiest there. 1 is probably what I would use also. So maybe I choose 112. So I know A, remember, is 4, and then I've got B to the x. So I'm going to use 1 for x and 12 for y. Divide by 4, and I get B is 3. Now, if I'd used anything other than 1 here, I would be in the situation of having to take a root. If that was 2, I'd have to take the square root on both sides if it was 3. So try to use 1 if you can. It'll just make it a lot easier for you. Now we can write our equation, yes? Yes. What's the equation? Is that the same thing as 12 to the x? No. It's not 12 to the x. Why is it not 12 to the x? Exactly. That's exactly right. I'd be going out of order of operations. I have to do the exponent first. You try to write the equation for h now. See what you get. You got it? You already got it? I'm impressed. You're going to do the same steps, but you don't like the steps. My gosh. That's not how you learn, Brett. Zero 8 tells me that I have 8 equals A times B to the 0. Of course, that's 1, so my A has to be 8. And now I'm going to use the point 112 to plug in, or 12 to plug in. So 2 is going to equal 8 times e to the first. So what is b? 1/4. 2 over 8, which is 1/4. So my equation here is a times b to the x. Is everyone okay? That was easy. Okay, let's transform some parent graphs, then I'll be done. Maybe. No. What whole thing about growth and decay? No, you'll have to identify exponential or not. You'll have to talk about growth or decay based on the E or based on the graph itself. Other questions? All right, let's transform some. Is that exponential? Yes, this is exponential. Is it growth or decay? Growth. How do you know? The base is bigger than 1. That's exactly right. If you had to name a parent graph here, what do you think the parent graph is? Okay, so b to the x, but in this case, 2 to the x. These are a little different than having, it's not like our other functions where we just have x squared as the parent graph and then we transform it. These are all a little bit different. So the base that's there would be your parent graph, so 2 to the x would be your parent. How is g of x different than the parent graph 2 to the x? Which means what? It means it's to the right 1. So I know I've got this. Let me do the parent first. For 2 to the x, I've got this asymptote at 0, right? And I really just need 2 points to graph it. I could do 0, 1. That's always going to be on the parent. And then 1, 2. And so now all I'd have to do to graph 2 to the x minus 1 is shift that over 1. Does that impact my asymptote? No, why? It's a horizontal shift. Horizontal shifts are not going to impact your asymptote, only vertical shifts. So this is g of x, and this is b. That makes sense. What's the domain of the green? I'm looking at the green, the g of x. Absolutely. How about the range? 0 to infinity. Why is it a parenthesis and not a bracket? Exactly. Doesn't include the asymptote. Let's do the same parent, but let's do h of x. What if it was? Do you see that the parent is the same? What's different? The a value. What is the a value doing? What's the transformation? A vertical stretch of 3. Do you agree? Has it moved my asymptote? No, it has not moved my asymptotes. The shrinks and the stretches are not moving my asymptote. So it's still at 0. The only difference is instead of 0, 1, I'm at what? Anybody? You're at 0, 3. And instead of 1, 1, 1, 2, I am at 1, 6. Because remember, shooting up a little faster. Vertical stretch is only impacting the y value. So you keep the x the same and you multiply the y by that stretch factor, right? So if it was 0, 1, a stretch of 3 would become 0, 3, and 1, 2 would become 1, 6, because I multiply by that stretch factor. Y'all remember all that? How about domain and range? It's exactly the same, isn't it? Okay, so to move it up or down, you tell me, Adam, how do you think you'd move it up or down? You'd add it to the whole thing. If I took this equation for h of x and I said plus 1, that would shift everybody up 1. So now my asymptote is at 1 instead of 0. Everybody good? What? We hadn't talked about E yet, though. I'm going to keep it in there, but I'm not going to talk to you much about it other than the fact that E is a number that can be represented. We will talk more about it Monday, but just so you know, so you can start getting ready, we're going to use a limit. We're going to define E a little differently than what we did before. I told you it's just an irrational number, and it is just an irrational number. It's that 2.718, kind of like pi, and it still does that, but this is where it comes from. This is the formula. If you get bigger and bigger for x, if you plug in huge numbers for x, you get closer and closer to this value for E. And so that's where E comes from. But you'll have some that you'll be working with this weekend that have E, and you will just look at that as being 2.718 or whatever, and everything will be the same. So if that's your base, that's going to determine your growth or decay there as well. Okay, I'll stop because